Ali,
Cool.
yeah, okay. I'll share my screen and we will go with the presentation first, and then we'll give the demo. Ali will talk first. Let me share my screen. I think it
Cool,
is this.
thank you. And yeah, I have to drop in 10 minutes, so I won't be here for the rest of the presentation, but I'm just gonna get it
Yeah,
started to Naren and the rest of the team to continue.
yeah, sure. I'll just do the slideshow and then. Yeah.
Okay, cool. All right, well, welcome to our final presentation to demo what we have done in the past 5 weeks, Team-2. Ali Ardestani, I'm the product/project manager for the team. Just wanted to let you know that I'm kind of merely face of the team here to present some of the slides, but shout out to the rest of the team that actually did the work. So, all right, let's get started.
Yeah. Yep.
Okay, so we're gonna start with some introductory slides, then kind of get into the steps that we went through and what we did in terms of building the tool, and then pull up the chatbot to do the demo. All right, let's move on. Okay, so let me introduce you to Peace Pal. That's the name of our mental health chatbot. When we started this project, the goals were in order to deliver such a tool, we wanted to conduct the in-depth analysis on understanding the impact of social media on mental health, and then develop recommendations and insights for the user in order to remedy potential issues that they may be suffering from. Next slide, please.
Yeah.
The way that we got there at a very high level, we're going to get into the details in the following slides, but first we conducted research on various aspects of mental health issues. Really, the goal was trying to understand how we can establish a balanced digital well-being. And then when we started getting into the work, we went through different steps and processes in order to basically build a AI and ML-driven chatbot. And visualize all that through using a flow diagram to help understand the architecture and how this whole thing came about. And then we packaged all that up using a user-friendly interface that allows user to interact with it in an accessible way, to ask various questions that may be related to depression, anxiety, and general mental health well-being. Okay, next slide. Yeah, so our focus for this tool has been on anxiety and depression, to be specific. We know that those two are symptoms of generally larger problems and then pretty prevalent disorders. So we needed to kind of train the model in order to focus on these two aspects and try to allow users to uncover potential root causes by asking questions that are related to these particular two symptoms. Okay. All right. The first step of the process was data collection. So we collected data from Twitter, from Facebook. We combined all that data sets for the pre-processing and went through the data pre-processing in order to extract particular valuable insights and sentiment and experiences from those. I just also wanted to let you know that starting from this slide and a number of other slides following, you can see the main contributors for different steps at the bottom of those slides. Okay, and at this point, I'm going to turn over to Naren to continue with the slides. Thank you.
Yeah, thank you, Ali, for starting this one. Okay, so this is the initial architecture we have submitted at the beginning of the project. So one change what we have done, right, like we have added knowledge base to this other than vector DB. We have this knowledge base, like we collected a few PDF files related to depression, which gains, RAG will gain some knowledge based on the queries posted by users from this PDF files. That is one thing. So it is like as part of we implemented our chatbot application based on this architecture. So we started with pre-processing, various steps we have performed in pre-processing. We will cover that in the next slide. What are the things we have covered? And we stored that into VectorDB, and then we used Mistral 7B instruct model from Hugging Face to retrieve the embeddings and then provide that to chatbot. So we have used I mean user can provide input through either speech or text. That feature we have implemented in our chatbot. So yeah, I'll go to the next slide. So coming to data pre-processing, we have performed various steps to do the pre-processing. As part of pre-processing, we did text cleaning, like removing unnecessary, unwanted characters, special characters, and then and then performed the lemmatization and stemming, stop word removal, and some we did exploratory data analysis as well. This is one of them, like we created word cloud from that. If you see from the word cloud, the most of the words we see mostly, right, like sad, really, worst, and economic. I mean, these are the these are the most frequent words we see from our data sets. So the data sets which we have collected is from Twitter and Facebook. Yeah, and then sentiment, and also after we perform the pre-processing, we did sentiment analysis. So we came up with the three different methodologies. I mean, we three different techniques. One of them is text bob, one of them another one is Vadder we used, and another one is Bert is from Facebook. Looks like Bert is performing better in doing the sentiment analysis. So it gave the labels like neutral, positive, and negative. Those labels were given by this model very well, and then we went with this Bert model. And then after performing this sentiment analysis, we created embeddings, and we stored that into ChromaDB. So we come to this XGBoost classifier also, like at the end. So this is for basically, like, as soon as the user enters some text, this will classify whether the text entered is negative, positive, or neutral. It will classify that, and we can see that on our UI as well. Let me go to this. And as I said earlier, like we used ChromaDB to store embeddings here. Uh, so just and yeah, so these are main for model building, right? We use these are the main three components we have used: generator, retriever, and then model pipeline we have used. So basically, generator is basically connect to Hugging Face and get the model, LLM model from Hugging Face, and retriever connects to ChromaDB, and it will retrieve the embeddings based on similarity search. And the model pipeline is the one which has all combined together, which utilizes both yeah, generator and retriever inside this one. And yeah, and chatbot UI. So I will cover this while I'm giving the demo. So basically, in a nutshell, our chatbot has a feature for giving input as a speech, or you can enter text as well. And we have even using XGBoost classifier, we are able to classify whether the text is in negative tone or positive tone. Those details we can see. So we used Streamlit for designing our UI chatbot. Yeah, so if you, yeah, yeah. So these are the features of our chatbot, like uh, managing whole app, right? Like we are able to manage the context maintain, and also it retrieves. As I mentioned earlier, like through we can provide uh, user input through text or audio, both ways. We are maintaining conversational history as well. That is another, which is part of our pipeline. So these are active collaborators. I have coming from the top to bottom, right? Like everyone involved very well, and so I like to thank everyone who actually helped the team, right? Like coming together and build our basic UI chatbot. Um, yeah. So okay, I'll move on to the demo. If no questions, yeah, yeah. So yeah. So this is the UI we came up with. Initially, we had only in the previous demo. You remember, like we have only text and speech, and we did not have the classification sentiment analysis added to that. I think that was the comment I think we got last time. We did not classify the text last time, so we implemented that. We have trained our XGBoost model based whatever the data we have collected. Based on that, we used that data for training and user input. Whenever user provides the input, it will classify. Currently, it is defaultly set to neutral, and based on the input, it will change. Yeah, let me type something. So now if you see, the user tone is changed to negative. Yeah, yeah. So and also we can play this response here. Text to speech module it's implemented already. Uh, so this is one thing, and it will ask the follow-up question also. Can like based on whatever we typed, right? Like we can. So can you share me some might be causing the sadness right now, and I'm here to listen, and it has that. So let me. This is just a follow-up question on the same thing. It is still the tone is negative. If you see, understand the receive negative comments on Facebook can be, yeah, this thing. Can you share me again? The follow-up question will be asked on the same thing. Can you share me how these negative comments specifically affect you, and what coping strategies? It is asking some follow-up questions on the same thing. We can keep going on that one. So I'll just stop for a minute if Yahya to provide any feedback or suggestions on this one.
Yes, no questions, right?
Yeah,
So what do you
sure.
think? So you only say like how will you are happy with your
Yeah, so correct. Yeah, so for as I said earlier, right? Like first thing, right? Like we actually wanted to implement feedback loop also using reinforcement learning. That is completely new for me and also to the team as well. So since we have the time constraint here, so we were not able to implement that, and also we wanted to implement this model evaluation also, another pipeline. So that would be more helpful. I would say that those are the things I see improvement areas in my opinion. So even a team can suggest if I'm missing anything. Swati or Asma, Misan, uh, please go ahead and tell if I am missing anything.
Yes, one more thing, like we thought that we will implement fine tuning also.
Oh yeah,
Okay, so
right.
Deltan worked on that too, but it needed a lot of computational power, and it was currently the model was overfitting, so we didn't include that.
Yeah,
Yeah.
one point to add to Swati whatever said. I think Meet has provided the fine-tuned model, but we ended up. I tried while I was trying to integrate that and ended up with many errors, and I did not use that model actually. Yeah, yeah, that is one thing I could not do it. Yeah.
Yes, yeah. The thing we faced is computationally, we didn't want a model to become slow. That was our concern. And that's why also we, like Narayan said, we had plans of implementing reinforcement learning. But with the time given, we tried our best what we could implement and not make our models slow.
okay.
Yeah.
So yeah, no problem.